ask you first, who's in here speaks Arabic? It's just like if you drop in the chat who speaks Arabic, that would be great. Um, the reason that I'm asking this talk is prepared in English manner. So if you speak Arabic, I can try to swing some Arabic language in the meantime. Well, if it's not, shouldn't be a problem. So I know recording as well gonna include some. So let's dive into it. So what I'm gonna talk about, it's how we build a platform engineering and developer portal in the New York Times and our journeys through the process of how we done that. But let me just like start by introducing myself. Thank you again for introducing me. So a couple things here. My name is Ahmed Bebars. I'm a software engineer and I'm especially a gopher with a few years of savoring the spice of backend development and system architecture and cloud management as well. So I work at the New York Times and I lead runtime platform operation, ensuring that everything runs in a scalable infrastructure way for our products. So when all of the code is compiled and all of the clouds are well managed, you can find me exploring the unseen worlds underwater. Scuba diving is one of my favorite passions that I always want to do, and also spending time with my family. So oh, we have an Arabic speaker. That's nice. So let's start into talking about platform engineering and embark an enlightening journey through the developer's world. And let's explore and have some fun. So here are the main agenda for today. So we're gonna talk about like why platform engineering, and then we're gonna head into like how to build an IDB or an internal developer platform, and then our platform journey at the New York Times. Before we start, let's get into a foundational understanding of what platform engineering really is. So, by definition, platform engineering is a discipline focused on modeling and delivering a consistent experience that optimizes the process of development, deployment, and monitoring for engineering teams. It emphasizes a self service approach, allowing teams to access, manage, utilize all of the tools that they need to run and deploy their service with minimal friction. Well, let's break it down a bit. So the consistent experience here, it refers more to the creation of unified standard environment where developer can work seamlessly. And if we switch in Arabic, من الحاجات المهمة ان لما اجي ان انا ابني السيرفيس بتاعتي، المهم ان انا يبقى عندي نفس الاكسبيرينس الموجودة كل مرة. مش النهارده بعمل حاجة وبكرة لما اجي اعمل حاجة ابني سيرفيس تانية الموضوع يختلف. The other thing is the self-service approach, which is more about empowering engineers to have the autonomy to access resources, manage workflows, resolve issues independently without the need to go to any platform engineering team. So like that accelerates the delivery timelines. ده أهم حاجة في الموضوع إن لما بنبني بلاتفورم إحنا مش بنعمل مش عايزين يبقى فيه request based اللي هو انا تيم عايز ابني سيرفيس، هروح اكلم التيم ده اقول له لو سمحت انا عايز الحاجات الفلانيه. لا، المهم ان الموضوع يبقى سيلف سيرفيس ابروتش where like التيم ده يروح انا عايز السيرفيس الفلانيه، كليك كليك، كل حاجه موجوده. Lastly, provides extensible tooling, means that the platforms are designed to be flexible and adaptable, enabling the integration of new tools and technologies as they emerge. So, in essence, platform engineering is about crafting an adaptable and efficient and collaborative environment that empowers developer to innovate rapidly on the platform. So, it is not the end goal. It is a tool or something to help engineers to build on top of it. So, it's a product for a product. So, we know what platform engineering is, but why do we need it when we already have ops teams, DevOps, cloud engineers, all of that already exists? So, like, why the term is coming to the light and why a lot of teams and companies are starting building like platform engineering teams internally? So, the answer is simple. As technology gets more complex, operations gets bigger, we need something to bring everything together. So existing teams do great work, but platform engineering combines all of their efforts, making things smoother and more much efficient for everyone involved in developing software. It's like taking all of the good stuff from different roles and mixing it all together into a super team that will focus on improving the experience. And it's important to focus on the experience here because it's not about the infrastructure. The infrastructure itself, like we already built that into many layers and many roles before, but like we are focusing on the holistic idea of the experience. And we'll dive deeper into like why platform engineering is so crucial and how it stands in the world filled with various tech roles here. So traditionally, the realm between software development have been bifurcated into development teams responsible for crafting software solutions, and then we have ops teams that are responsible for managing deployment and infrastructure. While the division was conceived to specialize and optimize both ends of software development lifecycle, it's inherently cultivated silos because, as you can see here, there's a silo between the dev team and the ops team. The dev team is trying to embrace for something, which is usually a business change that they want to get out of the picture. They want to make sure this feature is delivered, but the ops team is making sure that let's make the systems reliable, let's make have an SLO, and there's always that barrier in between the two teams. So that's why, like in a normal world, we have developed to DevOps. So we had our dev and ops teams working in their own world, and we wanted to bring something better together. That's where DevOps comes in. It's all about getting development and operation to play nice, making software releases smooth. So it breaks a wall between the culture of everyone working together. So certainly the evolution from traditional dev and ops teams to integrated DevOps brings several significant benefits. Like we have enhancement collaboration because now they understand the goals together. They understand like the development software lifecycle and everything is needed there, and they also understand the reliability out of it. But also increase the deployment frequency because when we merge the entire software lifecycle, we bring CI, CD, all of the things that it's needed hand to hand. Faster time to market, like the issues that we had in the past were like it was very disconnected between like the operation and the development. Now we can accelerate the development lifecycle and stream the workflows. And the quality, reliability, and the efficiency, and all of the other things that comes out with DevOps, it's been a game changer in meeting the demands of cloud heavy world where like we moved away from like servers on-prem and all of these things to a way like, hey, we want to deploy faster, we want to have better rules for the cloud and allow us to like operate in a much better way. But that's where platform engineering also comes in. Takes the good stuff from DevOps, adds even more to make our software development and deployment super streamlined in a world that's all about the cloud. But as technology raced ahead, we are seeing new tools, platforms, and framework pop every day. This constant change is exciting, but also brings a load of new things for our teams. This diagram is like from last piece of it. It's in 2022, but I think like there's a new diagram about like 2024 that I have seen around, but I didn't update yet. But think about the cognitive load as a brain power we see and we use to learn and solve problems. Back in the day, we only had IDEs and code and something built in house, all of the code, all of the components built in one monolithic app, and things work. Then we evolve every like 5 or 10 years. We get to see things like from like, hey, we have code and ship, we have cloud, we have SOA for services. Then we get to Heroku and we get to all of the other fun stuff, and we're still on the monolith, but like we move towards like microservices in 2015, and then like code ship and run, and now we are talking like about Kubernetes, cloud native, microservices, so serverless, all of the kind of stuff. So this rapid evolution, while opening doors to new possibilities, also brings risk of information overload. So it can make decisions tougher, and it can take a toll on focus for productivity. So it's crucial for us to find ways to make this easier on our teams. We need to streamline our processes, pick our tools wisely, and support continuous learning to help teams stay resilient and agile. So let's run into an exercise. Again, I'll give you an example on that. These are a few colors. Think about think of them as color palettes. And if I ask every one of you here to mix them together, I just want you for a minute to imagine how your team would build these tools together. So these are just like some colors. If you imagine, like, I give you a canvas for it, and then I ask you, bend this canvas with these colors, what that would look like. So I will pause here for like 5 seconds, let you imagine this. I know that's awkward silence, but that's the game of the exercise here. So let's come back to it. So you can see now that if I have multiple teams and they are all familiar with all of these tools, but they're gonna build different stories, and I hope like that's what you came up with. So let me know in the chat if you came up with different idea. But like the idea here is like you can see like all of the DevOps teams have the same tools, but they build things differently that fits their use case. I'm not saying that their use case is different from others, but like there are a lot of commonality, but they built whatever made them work faster or easier because they have the tools, they can build it. It's a Lego blocks, and we give them that. So in here, our goal is to help them to build a unified experience that's faster, easier, and can be adapted into their workflows and keeps them focused on building the application themselves. And instead of figuring out how to put this Lego pieces together. I'm gonna jump quickly into a big into small piece of the CNCF landscape. It's bigger than that, but that's what I could fit on the screen. So believe it or not, there are many tools out there, too many to fit in a single screen. So you can go to the CNCF landscape and see this is an old screenshot. So I believe that's been updated. But again, CNCF stands for Cloud Native Computing Foundation, and it has loads of different technologies, each doing something unique for a cloud native project. This richness, while it's cool, it shows how fast technology is growing, and that might be overloading for people like trying to understand like, oh, I'm still coming to my application in cloud native. Which tool should I use, and what is the right combination between tools? So makes the world complex in general, like what tool to use, all of the kind of stuff. So let's take another step and talk about the idea of having everyone in sync while using different tools. It's like trying to get a bunch of different tunes to play nicely together. So picture an orchestra where every musician is playing their own thing. It's kind of cool at first with everyone doing their own creative thing, but soon it sounds like noise because there's no shared tune between all of these. So this is what happened when every team picks and chooses their tools and ways of working. Sure, every tool has its perks and every team has their favorite, but when they don't match up, things get messy. I want to give you like a quick example. If you have multiple teams in your organization, and for example, you ended up having like multiple teams doing different things, and you want to like be helpful to many teams. Like, imagine how hard it would be for someone to understand the context behind when it's built. So, if a team using Jenkins versus a team using GitHub versus a team using AWS Cloud Development Kit, which like it's just gonna be like a lot of cognitive load that you have as just an engineer to understand to help people around. So these are all of good tools, but we're not talking about the tools. We are talking about the experience that someone has to go through. So let's dig a bit deeper and talk about how we can focus on specific tools like AWS Kubernetes and Argo CD to build an abstraction, for example. So when we hone in into specific tools and build abstraction layers, we need to standardize over these tools for whatever we can offer to the organization. So we'll take an AWS for instance. It has a comprehensive cloud service platform. By building abstractions around AWS service, we can provide teams with streamlined, easy workflows that reduce all of the complexities that they might have on things like, hey, I want to just get a container running. I just want to get a database running. I want to get all of these running. So if I listed these into like different layers on how this would work, that would be like source control. So we pick a tool, GitHub, for example. Uh, so CI/CD, we have if we pick the tool, it would be like maybe Actions, maybe Argo. Like there's Flux as well. There's other CI tools. If we pick the runtimes, that would be Kubernetes, because Kubernetes for like simply managing the containers and focusing on like creating abstractions around this would that would be paving the roads for a smoother and coherent development cycle. So teams don't have to think about like what I really want to do. Like they just need to think about like, I have a container. Can you run this for me? So when we do all of that together in a good way, we are not just providing an easy way to navigate path, but we are also ensuring that despite the diversity of tools and processes that we have, the end results are working well together in a good way. Is that like the process and the experience is much better. So if I talk about this more in Arabic, لما نجمّع كل الحاجات دي مع بعض ونخلّي الموضوع بطريقةٍ ما إن هو أنا مش محتاج إن أنا أقعد آخُد خطوات كتيرة عشان أبني الinfrastructure بتاعتي للteams، اللي هو طَب أنا عايز أعمل service، طَب إزاي هابني الservice دي، طَب إيه الprocess بتاعة الdeployment، طَب إيه الprocess اللي أنا هاحُط فيها. أنا كل اللي محتاج أفكّر فيه دلوقتي أنا عندي experience، أنا it's a few clicks or مجموعة من الخطوات هاحطها علشان تبقى جاهزة إن لمّا حد ييجي يقول أنا عايز أعمل service أو عايز أبني service، بييجي هيclick على كذا حاجة وهيلاقي الخطوات كلها مبنية بالنسبة له. So if we focused more into a centralized operation and the concept of paving path to develop tools in a more harmonized way, when we talk about centralizing operations, mean we have a core and unified approach to how we manage and deploy our tools and processes. It's like we're having a central hub where all of the development activities are harmonized together, making it easier for every team to be on the same wavelength. Now, the idea of paved path is essentially creating clear, well-defined pathways or guidelines for developing tools. It's about like setting up preferred methods and processes that are tried and tested. So we are not limited to a specific set of tools, but like we're just trying to make the experience smoother. Like the user or the engineer behind or the engineer building a service doesn't really need to know all of these tools like in depth, but they know like enough about that they can start like easily just like say, hey, I want to deploy a new service. Here are a few parameters. This is how I get things created. So like, and when we do that and we have a centralized operation, imagine that like all of your teams follow the same process. So in that manner, like you can call any engineers that understands the deployment process because it's one, and then like they can be able to have more contribution to the process. But let's talk about one thing here. So what's the difference between now, like we talked earlier about ops team versus dev team and the silos between them. So isn't just this another silo when we create like DevOps team, platform teams, they operate differently? Actually, let me clarify something here. Centralizing operations and BAFBAT is not about like building walls. It's about laying the foundation. So the goal here, or not for the platform team to start something, but like they are establishing a baseline or a common ground to build an integrated developer platform, which we will talk about next, and create like an efficient workflow that fits other teams. But teams still can take all of these like build pieces, like build workflows together and customize to their exact need. But it doesn't have to be like a very like distinct customization. It will be just like adding a couple things here and there, maybe like adding another tool if the platform supporting it. So this approach is far from creating silos. It's about building bridges between two different domains, ensuring that we have communication between the platform teams, all of the teams that we have in one place, and make sure that they can understand how to operate their tooling and platforms. So while we define what's platform engineering, let's like take a look into like how we build like internal developed platform. So I'll shift focus here on the developer journey. It's much like a customer journey with a product or a service. Developers try to like do something. So like think about like when you try to buy something as a customer, you just go through like a process of how you buy things. So same developer executes something similar. So I'm highlighting here are some of the steps that mostly it's common between any service development or any developer can want to build a new service. So by recognizing and understanding these common patterns, we can develop strategies uh, around. Sorry, I got distracted by the comment. But we can develop strategies around like how these points can be common between different things. So let me just close this for a second. Okay, so this is a way how we like just understand like what steps that need to get like in common, and then how we build a platform on top of it. So we might pose and ask ourselves, do we really need an internal platform into an organization? And to address this, there's a few questions that we need to talk about. Like basically, we're going to start with standardization and consistency. Like an IDP brings uniformity and standard practice around the board, reducing the chaos that we talked about earlier. So it's just like easier workflows and between varying tools. Talk about efficiency and speed by providing streamlined workflows and integrated tools. An IDB facilitates quicker and more efficient development cycles, enabling teams to deliver products faster. Also, another thing is integrations. Integration and collaboration in an IDB acts as a cohesive platform where various tools are working together. You don't have, as a platform engineer, you will take care of this, but like as an end user or as an engineer that consuming the platform, like all of the tools are integrated. So like when you click like, hey, I need a new service, you get your CI, you get your CD, you get your runtime, you get everything combined together. And if you offer as an IDB like different tools, it just like it's a matter of integration, or it's a matter of how you abstracted all of these together. Talk about flexibility. So it's scalable. So, or scalability and flexibility. So it offers a scalable and flexible environment that like you can grow and adapt more. So like once you build it, it just like a user will use it today, tomorrow, and after, and that allow expansion for the platforms. So it makes the process easier to scale. And the last thing is about visibility and control. So when you have a centralized operation in an IDB, usually means you have a service catalog, so you know which service talk to which service, what's being built. You have a greater visibility into the development activities, and you can like have different control over processes and workflows that you can do. So reflecting on these pillars, it becomes clear that having an internal development platform is not just about having a set of tools. It's about creating an unified experience for your organization to adapt and build on. But one of the questions that we ask ourselves usually, and you probably would ask yourself too, like, okay, now I know that I need to create an internal development platform. Do we build it or do we buy it? And that's an important question. And you have to ask this to yourself and to your team and to your organization, because it involves a significant time and effort and resources. So there's no one size fits all in this situation. Like practical approach is to start small, begin with an MVP, minimum viable product, test how things are working, understand what your teams need, what your organization need, and then allows us to like validate your concepts, refine your objectives, and adjust your strategies based on that. So that's how you go from there. So whether you're building or buying, or like bit of both, you might like buy a couple tools and integrate with something you build inside. Like the whole idea is just like if you have to offer a unified experience. And to talk more about this, I want to talk on into like how I think on like the platform data model, or like how I think about like how you can integrate multiple services together. So the goal here is to make a structure that's strong but also able to change and grow. So one of the hardest questions I usually ask is like, if I remove this tool, what friction that it would create, like, or can I swap this tool with another thing? Because once you build something, you have to ensure like these pieces are swappable. Not everything in the same manner. Like some things are harder to swap than others. But we want to talk about like we are creating a model that it's away from any tools. We're talking about like a service needs to have documentation. A system has an application, and a system is part of a domain. Then we talk about an application, it has a dashboard, has a workload. So all of these pieces that I brought here, it doesn't have a reflection on any tools. It's matter of like, that's my mental model around like how you build a platform data, like a platform, an adaptable platform data model. And then you can start looking to in depth, like, oh, okay, so a workload using packages, what packages mean? It could be a Go package, it could be an NPM, it could be something else. So it means that we need a registry. But like, I didn't specify which registry I want. That would be like something that you have to figure out what's your organization want and how to use the right tools for your platform. So jumping to like how we build our workflows or how we transition to like what is the workflows that we need or what's our ultimate goal. So we started with like creating like a few things here. So first, teams comes in, they need to create an onboard or service. They just like have a workflow to go through. So, and then once they say, hey, I need my service, they get a source control. They get their CI/CD, which provides them with all of the abilities to build, test, and deploy their services. But they also get the runtime out of the box, which is something that it's built and abstracted for them. So they get to like just use their services comes deployed to that runtime. And another thing, they get their ingress out of the box. So that enables them to route their application traffic through a shared ingress model, which offers diverse capabilities with different routing options. So the idea here is that this holistic approach encapsulates a developer journey crafted for teams. So like we got like all what they might need, and then we created in an entire set of workflows that they can just like have to build their own services. So let's dive deeper into like each of these building blocks around how we do things. And sorry, I forgot like also there's an observability layer that we have across all of these workflows, so we can understand like what's happening in each layer, what's happening in the develop workflow, what's happening in the run, what's happening in the route workflow. So I'll go quickly over like each of these because I know like we are running short on time. So if we dive into like that create and develop workflows, we are talking about blueprints. We're talking about shared libraries, artifact registry, something I mentioned earlier. Just like it's easier to have an application templates. If you know your organization is front end heavy, it would be great if you can have like these templates ready and built so you can just click on them and just like get them crafted quickly. Another thing that's important is you have to take a look about shared libraries. When I talk about shared libraries, it doesn't mean that specific programming language shared libraries, but it could be anything. It could be like a Terraform library. It could be anything that it's commonly shared between like different services, and that could be have a reusable code pieces that people can just use out of the box. The artifact registry is, or like an image registry, it's also another component that you can centralize in your hub to manage all of your container images. It has different ways of like how you can offer this, but if we're focusing on like having all of these build blocks, we have like an easier way on creating and developing the services. We talk about like the build, test, deploy workflow. We are talking about like different layers. We are talking about like a build process, which we have continuous integration, a CI tool that is just like focus on integrating application code continuously. And then we focus on testing, and then how we build like testing tools that allow teams to just like quickly test their applications. Then we talk about deployment, continuous deployment, talk about strategies. One thing that I mentioned earlier is Argo CD. And once you combine all of these together, you will get like this smooth workflow for like, hey, I already pushed my code. Now my code is getting deployed. What are the steps and the workflows that I have to do to get my code into different environments, for example? The other thing that is the runtime workflow, which is usually like, hey, I have a runtime. It means like I have a container. If we bake on Kubernetes, that would be like, hey, ship a container to like Kubernetes, or I can ship a container to serverless, or I can ship a container to machines that would run it. That's one of the layers that you would need to have. The other things that you'd have like some of the cloud resources, where like how to manage that. Usually like an application, most of the cases doesn't come empty. What I mean by that, it doesn't just like have a programming programs that runs have also like a database. It might have cache, it might have different things. Another layer we talked about is the routing, which is here we are having pathways on like how your traffic comes in to your service. Like this is a primary focus on having a centralized ingress that serves as unified entry points for all of the services. CDN layer might be appropriate for a use case where like you serve a lot of static content and you just like need a CDN in a use case where like just like you cache all of your traffic at. Talking about the monitoring workflow, it's great to have observability. You need to understand availability and incident management well. So like to ensure like your system is paramount and you have established clear efficient basis for incident management at this level. So enable you to respond to instance as fast as you can and minimize any impact. Cost management, it's always, we're in a cloud way, so it's always good to focus on like the cloud cost of like whatever you're building, how is it efficient, how we operate on that, and all of the kind of stuff. So now if we took a holistic view about like how is an internal developer platform look like, it would look like something like this. There's like few layers that you can look into it, but like talking about the developer space, someone like having access, they have an interface to deal with your platform. That's where like they operate in. They operate in their IDE most of the time. But then like there are some platform interface, either like you give them a UI to work with, or an API or a CLI. Doesn't matter. Just like they have an interface that fits your organization. The other thing is like they have some application definition and they have source control that usually how they like operate on their application specifically. And then talk about the second layer, which is the platform space. That's more like where you build like all of the CI/CD resources, your runtime monitoring, security, all of that pieces connected together. So that's where like it bridges the both worlds of like developer space and the infrastructure space, because that's all it's built on the cloud. So like you have that layer in between, and finally that's your foundation, is your cloud. Doesn't have to be cloud, but since we are talking about cloud native tooling, it's mostly is going to be cloud, but that could be your on-prem, that could be your networking on on-prem. Just like that is the infrastructure space that usually it's far from like the end user, because like we're talking about complexity, so we don't want to make sure, we want to make sure that like they don't have to understand all of these pieces to develop their applications or services. So that wraps up to three pillars of a platform. So let's circle back on the things that I mentioned earlier in the definition of platform engineering. So first, consistent developer experience. We aim to offer consistent and seamless experience for developers. So when you do something today, it's the same like tomorrow. It's the same like other teams trying to do the same thing. Self-service approach, it's critical piece. So you don't want to like have a backlog of like, hey, I want to create this service, hey, I want to change my route to do this. Like you want to offer the most autonomy to your end users, to your teams, so they can operate on your platform. The other thing is extensible tool. I think I alluded to that earlier, which like a tool working tomorrow doesn't mean it's going to be the same in a year. It doesn't mean going to be the same in 5 years. So you always have to build that mental model of like swappable tools and things like you have to be intentional about, like how to focus on making some of these things abstracted in a way that like you can swap pieces out. Maybe like a new request for another CI tool comes in. So how you fit this into it. So if we focus on these three pillars, like the consistency, the self-service, and adaptability, that would make the core platform. And we are not just building a tool, we are building something that will continue over the year. So the most important piece here is you have to focus on, this is not a project, it's a product. It's something that you will continue to iterate on day over day, month over month, year over year. So now I'm gonna walk you through our journey on like how we got to build an internal developer platform at the New York Times. So basically, starting with the basics, we started with like, hey, we have different tools, different hosting options. Each app team has their own way of doing things, bring things together in the next life cycle of it. So we try to bring things by managing our cloud resources in one place. even the app teams are still creating and managing their own frameworks. Was a step towards making more like cohesive organization. And then like we looked into like how we are building like a unified platform. Fast forward to now, we have built a centralized platform that helps everyone to follow the same best practices and workflows. We are all on the same page, and it's making our life a lot easier. So looking back, we have been through a lot of changes, always aiming to improve and work better together. So our current IDB offering is like this. So this is an exact like diagram of like how we offer services to teams. A user goes through like the same steps that I talked about, from like create, build, test, deploy, like operations and runtime, cloud, ingress, observability, all of that kind of stuff. And you can see like most of these are open source components that we are using. So it goes through a template engine, your CI, it goes through automatically container runtime on EKS that it's building, like all of the builds and whistles that you need, and all of that is been already built there. So at this point, it's just like this is what we have. But let me walk you through in a couple things about like how we have self-service in that manner. So starting with like I'm a team. I'm trying to onboard to your platform. I don't have an account. We're running a multi-account architecture, but like I'm not gonna dive into this, but I'm gonna like walk you through the workflow for that. So backstage, they request access, submit a request, and then behind the scene, there's like a workflow that happens. We'll like, okay, let's create an account and do an orchestration. Once we do an orchestration and an account is created, we give them like access to the account through GetOps approach. So like they have all the Terraform needed to the account and everything. But that's not all. We talked about like Kubernetes and EKS. So we also onboard that team to the runtime platform directly. So that's where tenant onboarding comes in. And that account is already connected by networking and connected by other ways to like the platform. And then at this, they are ready. The tenant is ready and they can start to operate. Another way of doing things when like you start making an application, same flow. Go to the same portal, submit a request, an application pipeline comes in, start to orchestrate the application, gives them like a repo where all of the blueprints, all of the configuration, but also like the application is deployed out of the box. Gives them like all of the tools, the deployment, CI, CD, image created, everything. So at this point, they just start coding, so they don't have to do anything. So all of that is being created. Many apps could start with an empty scratch image, so they can go through wherever definitions that they want to go for their app. But there are also some templates for specific application backend codes or front end or anything like that. So takeaways, I will be quick. Use the documentation. If you don't have this, it's gonna make you a lot of pain because you're just gonna have to answer a lot of questions. So you have to focus on that. Adoption and partnership. You need to find champions in your organization that who really like want to offload this to a platform, and you work with them to make sure that like understand their pain points and how to improve on that. Uh, Someone is at the front door. Forgot to unmute that. So you have a platform as a product, which, like as I mentioned earlier, this is a product, not a project. So it's one thing that you have to keep in mind. Another thing is the customer feedback, and this is critical because this piece is like as you develop a product, you have to keep working on that. So that's one thing that you have to walk through. But that's the end of it, and I know we only have a couple minutes left. So thank you all for listening and tuning in. I can welcome any question if you have any. Okay, let me open the chat.
Question?
May I know learning path for platform engineering? I don't know what you mean by that. Uh, can you elaborate, please?
Mehdi is expecting that how can become a platform engineer or how can get into the role of a platform engineer.
Got it. Okay, that's a good. So okay, now I understand. So I don't think it's a formal like set of tools that you have. It's more of about understanding of how you do. Like it's as I mentioned earlier. Like it's uh evolution of many things. So like when I started early in my career, I started in software development. Now like I work more on platforms, but it's just a process of like now I understand the software development life cycle. Now I understand which tools. Now I can provide it as a service for others. So it's just like a combination of many things. But mainly if there's things that you want to focus on, because also we can take it narrow to like you can be a platform engineer for like infrastructure piece, which is like could be like a runtime. So you can be only focusing on Kubernetes, but like you can only be a platform engineer in CI or CD. So it has many ways. So it's more about like the the T shape where like hey you understand like how platform works and then focus on a specific area. So I would think about like it's more like start with cloud native. There's a lot of good option and things that moving this way from like container runtime to service mesh to like secrets to many things. Great. Do you recommend in-house platform development if it's out scope of budget? Um, it's possible. Like, here's the thing. Like the one thing that I want to be honest with you. If it's out scope of budget, is it is it like hard to like quantify the value out of a platform? Because it's also like developing a platform requires people to build a platform. So while you can like get a lot of open source tools, you still have to invest some time. So I can't tell you what is the exact situation we have to go through, but like always with each piece there's a pros and cons. So if you buy something, means like you don't maintain it. It means like you offload this to someone and gives them money. But if you operate it yourself, means like sure you can use open source tools and operate it yourself, but you still have to get a team behind it because once you push this to your organization internally, someone has to answer questions because it's a product. It's not just like a project. You're gonna ship it and then wait on like people know how to use it. So the whole idea is like you want to provide them with a better experience. So that's one thing that you have to work on. So the value is you have to find the rational value first and like why are you doing this before even deciding on building or buying. If you can get like where this gonna be, uh that's gonna be difficult. But yeah, if you have in-house dedicated resources, that would be the way to go. And you can start building something, and then that's back to the MVP, as Sarah was saying. So it's really up to like when we say money, it's just like or we say budget, it's just like hard because budget also is not just about money; it's also about resources. So that's where I'm coming from. If there's no platform team, how we can adapt current teams to adapt inside the organization? That's a very good question. So if there's no platform team, someone has to start it somewhere, or someone has to have the vision for it. Doesn't have to be called platform team. The idea here is more the experience. It's more about like who offers these tools. There is a team somehow offer like these tools. They have some manage some infrastructure. It's not like everyone doing their own thing. It's just like you have to build someone has the experience to like put all of the pieces together. So it doesn't really depends also on the use case. I can talk to some things that I don't know much about, but you're gonna be the best judge in like how to influence others for like where you can save some time on doing things. So that would be one of the best cases here. And if we have build and run teams, which one will be? Yeah, like there are many. Like here's the thing: it's a journey, so you have to embrace the entire cycle of it. You have to see like who owns what, who built what do you actually need. There's different things like I have seen teams which like 5, 10 people operate like a platform successfully. I have seen organizations, they are bigger and they have like hundreds operate things. So it really depends on like a lot of all of the things. I realize platform practice especially for tech startups with limited time and resources. That's a good one. I don't have a straight answer to this. It's more about like the startup mentality is just like you have to go fast and build things. So that might not be the right time for doing this. Maybe like you could like get a couple things that help you through the process, but like this process, it's need an investment. When you're starting to build a platform, especially if you're building it. If you're buying it, that's a different story. Because you just operate it. So like you have something that's already built, but if you're building it, that's a lot of investment you have to go through. So the first thing is like usually you have to go with the org, like the organization goals. Is it like, do you have a friction? Do you want to prevent a friction from happening? Are you seeing that? Because you may have like a in a startup, also depends on the org size. I don't know what how many teams. Could be like 2 3 teams. So like, is it really they need like to have all of these bells and whistles there, or is it just like small? But like you are the only, so again, as I said, there's no one size fits all, and you have to be the judge for what do you need, because SaaS solutions sometimes, as Sarah mentioned, are not the good thing. Maybe we work in an industry that like regulates like how to use SaaS solutions. So like there's a lot of factors here that you have to get and think about. So if you have a dedicated team, we have fixed it by having dedicated team members working only on tooling. Sure. So now you have a team that only worked on tooling, so that team can start be a platform team and just not just like. But think about again, it's not just about developing the tooling; it's developing the experience. So it's more about like, hey, we have few tools, we have CI, we have CD, we have all of that pieces, and they are all working, which is great. But the experience is still it's not cohesive all around. Just like that's where what I meant by a platform, just not offering singular tools in a silo or in a ways and they are not really out of the box connected. It's more about all of the connections together that makes a better experience for your end users. I know we are out of time. I believe that we're like 45 minutes and we are like 6 minutes after, I believe. I happy to stay a few minutes more if anyone has more questions.
Thank you, Ahmed. How was your experience with Backstage? I'm assuming that you used Backstage as I saw it in a slide.
We do actually. So getting honestly my experience, I like it if you have it working the right way, because it's not just about you have a good UI. It's about connecting all of the pieces together. So the ways that I would see it, and the ways that if you don't go to Backstage to know more information, if you don't like Backstage to me or any IDB, to be honest, is the ways that I go to a UI or I go to something, I create my services, I understand how these servers are connected to each other, I get all of my basic metrics, and the ways that I always want to go about it is that we are not trying to make all of our eggs in the same basket. Like it's just like let's not reinvent everything. Like if you use, for example, Neuralink, if you use Datadog, let's not reinvent all of the monitors that happens there. But at least like that would be your entry to get to there. So far it's my experience was good. It has a lot of anything open source comes from the open source community. Like you can contribute back to it. It's open source, so you don't have a lot of like I have to submit a request and wait. You can contribute back to yourself. It comes with its pros and cons, but like as any open source tools, it's open source. You run it, so you would go into like any problems that you have to solve with your teams with your tooling. So I would say like my experience was Backstage personally, and in the organization was good. So
So
Thank
that
you.
was quite interesting and a wonderful session. Is there any more doubts? else we could find it out. Okay, so I think that's it. So I'm sure you all got enough insights from our very experienced speaker, Ahmed. I thank Ahmed Bebars for coming for us and taking his wonderful session in the name of CNCF Riyadh.